And welcome back. Today we're on page number 244. We're looking at fossil clues. Some plants and animals that lived millions of years ago have left clues about their lives. A line of footprints preserved in rock can show how an animal walked. The skeleton of a small animal can help scientists understand what the animal looks like. Skeletons and footprints are examples of fossils. A fossil is the remains or mark of an animal or plant that lived long ago. I like it that it says an animal or plant. And we've talked about that many times in class. It's the remains, it's the mark of an animal or a plant. Scientists can study fossils to learn about species that are extinct. Extinct is just a species. Species is another word for plants or animals that no longer exist. Here's a great example of a fossil right here of the trilobites. I think we talked about that when we Skyped with one of the national parks. Here's a paleontologist looking right now, working to remove sediment by sediment, piece by piece, to unearth whatever fossils they can find right there. A paleontologist. I messed that word up. Paleontologist is a scientist who studies fossils. If you ever get to go to the Naharo Museum down in Diboll, Dr. Naharo loves to speak with people. He is a paleontologist. How fossils form. Oh, look at this. Some lovely pictures of sedimentary rock layers going on there. You can see all the different layers, the different sediment that used to form each layer. Here's how the fossils form. An animal died and sinks into the bottom of the lake or shallow sea. It's another one of those gloomy and doomy, sad days. Sand, mud, or other sediments settle upon the animal's remains, so then he gets covered over with sediment. More layers of sediment form. This is going to give more compaction, pressure. Over time, the rock layer above the fossil wears away, and the fossil appears on or near the surface. And there's today we can find the fossil right there. Of course, this takes lots and lots of time, and you do need an animal or a plant to die first, and you're going to need pressure and time and maybe some heat too. Here's some other examples of fossils. Fossils and living organisms. One way paleontologists learn about extinct plants and animals is by comparing them with plants and animals that exist today. For example, fossils show that some dinosaurs called hadrosaurs had large hollow crests on their heads. Paleontologists have different ideas about the purposes of these crests. Perhaps this is one right here, the crest on this head of the hadrosaur. One idea came from comparing hadrosaurs to birds called peacocks. Male peacocks have large, brightly colored tails. They use the tails to attract mates. Paleontologists hypothesize, or infer, that hadrosaurs may have used their crest in the same way. They can't prove what they actually did. Why did they have to have this crest? They can only make inferences based on the way it looked in the animals and plants they know about today. Fossils can also show how plants and animals have changed over time. Many living things today are related to plants and animals of the past. Fossils show that some extinct plant species looked a lot like modern plants. So, for example, compare the pictures of the horsetail fossil and the modern horsetail plant right here. They have some similarities, but they also have some differences. Perhaps they are related. So by studying today's plant, we can find out information about the extinct plant from way back then. Fossils in the environment. Fossils also show that Earth's environment has changed. For example, scientists in Kansas have found the remains of sea animals called ammonites. Ammonites are related to modern squids, but they died about 65 million years ago. In South Dakota, scientists have discovered fossils of giant sea turtles. These turtles lived about 70 million years ago, but are now extinct. What do these discoveries tell us? They tell us about the climate, about the habitat, the environment, then and today. Here's how Kansas and North Dakota might look today, but based on the fossils we found of the ammonite and the giant squid thingies, here's what it must have looked like at some point in history. So at one point, Kansas and South Dakota were covered, that's right, by water. So fossils can be used to figure out how the environment looked thousands of years ago. Look on page number 250. It's called a geologic time scale. Today we're up here at the top of the present day. In each different layer, you're going to find different plants and animal fossils, and we can use all of those to explain what the land looked like. How was the environment back then when these creatures, organisms, were alive? Cool, huh? Fossil fuels. You have already learned that the fuels such as coal and oil are a kind of fossil. Most of these fossil fuels come from the remains of organisms that lived millions of years ago. Scientists sometimes use fossils as a clue to where to explore for fossil fuels. If they find fossils of plants or animals from a certain geologic time, there's a chance they might also find fossil fuels nearby. And we've talked about fossil fuels before. They are not the best type of fuel for us, but we are using lots of fossil fuels today. But we'd rather switch over to, that's right, alternative energies. We're done on that page. Oh, wait, good. It's another page you can cut out. Page number 255. Well, this book does not like me, does it? So here's some vocabulary words. Metamorphic. You don't have to know that one. Mineral. You should know what minerals are. A rock cycle. You don't have to know it. Igneous. You don't have to know. Sedimentary. You need to know sedimentary. And non-renewable resources. You should know non-renewable resources. They also have paleontologists, inexhaustible resources, erosion, deposition, fossil, extinct, and renewable. Yeah, all those cards are really good. And you have 2 spare cards for anything else you want to go back and make for your vocabulary baggie. So you can push pause, you can cut those out, add those to your baggie. And let's move over to page 272. Looks like we're going to be talking about water and probably the water cycle. We'll just start with water. Well, one word we already know this year, water vapor. Water vapor is the gas form of water. It is invisible. You can see water vapor forming tiny water droplets as it escapes from the teapot kettle into the room. Water vapor forms tiny water droplets in the cool air as the warm air escapes from the tower. Here we go with the water cycle. Water is always moving on through and above Earth as it changes from one form to another in the water cycle. The water cycle is the repeated movement of water through the environment. The water cycle is continuous. It always continues, but we can talk about the different processes as steps. So the first word, evaporation. this is liquid changing into a gas. This happens with heat from the sun. And we said before, the sun is the most important part of the water cycle, because without that sun's heat, evaporation won't even happen. Condensation is when a gas changes back into liquid water. And this happens with cool temperatures. Let's go with cold. Cold temperatures from high in the atmosphere. Or it can happen on a cold drink or cold cup. Something that's cold. We've got to have cold for condensation. Precipitation. This is water falling from the clouds as rain, snow, sleet, or hail back to the Earth's surface. The water cycle can follow different paths, for example, condensation from clouds, but it can also form dew. Now, they didn't list this one, but this big area right here on the bottom part of your book, this can also be called the collection area. Any area where water collects on Earth's surface can be called a collection area. They're going to have runoff over in here. They're going to have groundwater slowly moves into rivers, lakes, and the ocean. And groundwater can be in the ground, under the ground, where people dig wells and stuff. I think we've written that down before already. So if you need time, you can push pause. If not, let's press on. Energy in the water cycle. The sun has a major effect on the water cycle. The energy of sunlight causes most evaporation, sublimation, and melting. Energy is needed to evaporate the water and to move the water vapor by wind. This energy originally comes from the sun. And that's why I say the sun is the most important part of the water cycle. You got to have the sun. What is weather? Weather. I think we've already done weather, haven't we? I believe we have. We already have these notes. We've talked about weather, the state of the atmosphere. We talked about barometric pressure. We're good on that one. Page 286. What is climate? We've talked about climate. You already have notes about climate. Climate is the average weather. It takes years, decades, centuries for climate. Yeah, we already looked at this. Factors about climate on page 290. We're done with that one. You don't have to know about elevation. You'll be okay. We're good on there. Let's go on over to page 301. Here's your cards you can cut out. You can cut out condensation, water vapor, water cycle, precipitation, weather, evaporation. Yeah, those are all good cards. And on the next page, you can also cut out climate, meteorologist, latitude, elevation. You don't have to know elevation. You should know what wind is anyway, and you don't need barometric pressure. If you want to add some more cards, here's some extra cards. So go ahead and you can push pause, cut out your cards, add them to your baggie. Good job. I hope you have a great day.